Alright, so today we're going to talk about taking the second derivative of an equation. So we've already know how to take the derivative implicitly once, so all we're going to do is we're going to do it again. So again, that comes from, this is how we know. Right here it says d2y. This stands for the second derivative, and this tells us in respect to x. So this is the second derivative, and this tells us respect to x. And we'll get into exactly where those 2's come from and how we're going to get them. Alright, so here we go. Step 1, write down the problem. 2x cubed minus 3y squared equals 8. So we want to take the derivative of both sides with respect to x. Okay, so we go ahead and do that. So the derivative on the left, the derivative of 2x cubed is 6x squared. And the derivative of 3y squared is going to be negative 6y y prime. And the derivative of 8 is 0. If you're confused about where that y prime came from, go ahead and look back at the previous section's examples. Remember that we can use y prime instead of dy dx if we want to. So now we're going to go ahead and solve for that y prime or the dy dx. So I'm gonna move this whole thing, this whole side of it over here, and I'm going to get 6x squared is equal to 6y y prime. Now what I want to do is divide both sides by 6y, and I'm going to get that y prime is equal to x squared divided by y. Now keep in mind, this is the same thing as writing dy dx. I just find it easier to write y prime. Alright, that's the first derivative. So to find the second derivative, we're just going to take it again. So we're going to do d dx to both sides. Now, this is where you get that d squared y divided by dx squared. Notice that right here, you have 1d, 2d, so that's d squared. So we have d squared y divided by dx squared. And this is equal to y double prime. And here, we're going to need to use the what rule? That's right, we're going to need to use the quotient rule. So we get the derivative of the top, prime, times y, minus the numerator times the derivative of the denominator, all divided by the denominator squared. So we get 2xy minus x squared y prime divided by y squared. So again, to go from here to here, we're using the quotient rule. Alright. Now the only problem now is we have a y prime left in here. So we have to get rid of that y prime. So we get y double prime is equal to 2xy minus x squared. Now recall that y prime is this whole thing. So times an x squared divided by y. All divided by y squared. Now this just comes up to doing some algebra. So again, to go from here, we substitute x squared divided by y for y prime. Okay. So now we're going to do a bit of algebra. We get y double prime is equal to 2xy minus x to the fourth divided by y squared. Now you could take the time to combine fractions. I'm just going to do it in one step. I'm going to multiply everything by 1 over y squared. So these are going to reduce off. And you're going to get y double prime is equal to 2xy divided by y squared minus x to the fourth divided by y cubed. Now if you wanted to, you could skip this step and go right to the canceling part. And you get 2x divided by y minus x to the fourth divided by y cubed. And we're almost done. The only thing is we need to make sure that we write exclusions, because the only number that y cannot equal is 0, because it's in the denominator. And the question is there anything that the numerator can't be, or that x can't be? And the answer is no, because it's in the numerator. So any number in the numerator is okay. All right, good. Pretty straightforward. All you're doing is taking the derivative twice and then plugging in for that y prime. Okay, good. So now what I want you to do is try this. I want you to determine y double prime if y squared is equal to x squared plus 3. So go ahead and try that on your own right now. Okay, fantastic. You've got an answer. Let's check. Let me just run it through it with you guys and make sure we're all on the same page here. Y squared is equal to x squared plus 3. So what we need to do now is take the derivative of both sides. So you get d over dx to both sides. And the derivative of y squared would be 2y times y prime is equal to 2x. And if you want to write, instead of y prime, write dy dx, that's also fine. So now you want to get that y prime by itself, so we're going to divide both sides by 2y, and we get y prime is equal to x divided by y. Okay, easy enough. Step 2, do it again. Take d dx to both sides. This often happens with implicit differentiation. You often need to use the quotient rule, so make sure you're really comfortable with it. So this is going to be y double prime is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the denominator squared. Okay? So this is going to be y minus xy prime divided by y squared. Alright, but we can't leave a y prime in our answer because that's not good. So we need to substitute back for what y prime is equal to. And y prime, recall, y prime is equal to x divided by y. So this is going to be x divided by y over y squared. We do a little simplifying. Okay, now we need to get rid of this weird fraction in a fraction thing. So we're going to multiply by the reciprocal of the denominator. These are going to reduce out. And you're going to get y double prime is equal to y divided by y squared. Make that a little neater. Minus x squared divided by y cubed. Alright, so we just have a little bit more simplifying to go. And we're going to get that y double prime is equal to 1 over y minus x squared over y cubed. Now sometimes the book will simplify it a little further. So y prime is going to be equal to, this is going to need a y squared to have the same denominator. So you get y squared minus x squared over y cubed. Either one of these answers is perfectly acceptable. And that's it. That's all there is to it.